Hello and welcome to another free code session. My name is Jason Bach, and I'm going to curse myself, so to speak, because I'm planning on this being actually a pretty short episode. Make up for all the times I always try to hit this goal of 30 minutes, and sometimes I go over, so maybe this one will be shorter. That's the plan. As you can tell, again, I'm doing this in the morning before the real day starts. Got my coffee, which I'm always drinking. I notice when I edit these videos, I've always got these pauses of drinking coffee, but I need to get the brain chugging. So did 2 videos yesterday. Doing this one as kind of a finalization of dub sharp for now until I make more progress on it. I'm trying to catch up to where IMMO's going to start doing assembly emitting, which will require IL generation and things like that. And what I want to get to is where he starts doing method calls, because that's really the last thing I need for dub sharp. So trying to catch up as much as I can. I finally got all the parsing stuff done yesterday, so let me just show you a couple examples of that, because I can't quite remember where I finished. I'm editing the last video from yesterday, but I don't quite remember where I left off. So if I do like 1, 3, 3 minus 4, and then I do 2, 1 minus 1, and then 3, 2 minus 4, doesn't matter. And we say run. Notice that I have this execution engine finished. So I don't really know if it's doing the right thing right now, but I do have the engine in this so that I was able to simulate, for example, if I come into this one here, I say make that one the startup, you notice that it's technically printing out Fibonacci sequences. It's hard to see. You have to like add, and then this keeps moving as it gets numbers. It's quite annoying. We see like 13 and 8 is 21, 21 and 13 is 34, 34 and 21 is 55. And so this code here, Fibonacci sequence, this actually that's what it does. And so you can actually use whenever to build programs. But what I need to do is have a lot of code here. Or I need to be able to support method calls. So yeah, so there's like, how do I handle defer, which of them print, defer does this, there's an again. Yeah, so that's where I need to be at. But if you notice, I have this execution engine finished, because what I'm doing now is when I get to run evaluator, I actually turn this on, because this should be actually going through, and I did step through it once, and running through the bound tree and the evaluator that's generated from that. So that's actually pretty good, because I now have the ability to run something even though it doesn't print anything out. So, and let me do clear here. What I'm going to do is just a really simple one. Okay, 2, 1, 4, but I'm not going to put the semicolon there. 3, 4, 2, and now I say run, and I am getting the error now on line 2, column 7, saying that I expected the semicolon, but everything else still gets right. 3, 4, 2, 3, 4, 2. So yeah, I mean, the tree is now working as good as it can, even under an error condition. So that's nice. That's nice. So yeah, I'm definitely making some progress here. I should, yes, let's go to GitHub desktop, because I should commit all this before I forget. Okay. So we'll say fixed parser to handle multiple lines, mostly. All right, let me do a quick search here on task list. Come on. There we go. I don't know why it was taking forever. Making that. I'm just going through the to-dos here. This should be a method communication on the context. For now, I'll do this. Oh yeah, because once I actually get function calls, I can do that. Is it possible to have a line? This is something I definitely do need to support. So yeah, you have to number. Let's see, maybe if I can do that right now. I can do that right now. So what happens in this case? If you have, you can say 4, 1 like that, but you can also just say 4 here. Okay, and if I remember right, let's go here. So an expression which evaluates a positive integer is an instruction to submit the line with that number to the to-do list. Okay, a single line may appear on the to-do list multiple times. Each separate expression which evaluates to a negative integer is an instruction to remove the line with the absolute value of that number from the to-do list. If the line in question is not on the to-do list, nothing happens. If it is on the to-do list multiple times, one copy is removed. The integer 0 does nothing but is legal syntax. Multiple lines may be specified commas. The number of times add remove may be an expression which evaluates to an integer, a negative number of times corresponding to change the sign of the line number, and 0 does nothing. To specify the same number many times. Oh yeah, because you could do like 1, 2, 2, 2, 2, but you may want to an expression which evaluates to a negative integer. I gotta read this over again. Is an instruction to remove the line with the absolute value of that number from the to-do list. If the line in question is not on the to-do list, nothing happens. So I think if I go back and I look at, because there's a version of this here, move the line with the absolute value of that number. Oh, so what you do is, if it's 4 here, you're saying take 4 and add 1 to it. If it's a -3, you're saying take line 3 and do a -1. So really, if I, like this, which actually shorthand for this. For 1, 3, -1, 7, 1. Okay, so that's actually what that's expressing. Okay, so it's if it's a positive number, then yes, you have to. And I think what you said. Okay, so what I need to do here is say I get a line number, but now I need to peek because I need to see if the next number is to see if it's actually a update line count token or not. So we need to say var next is equal to this dot peek. And 1? I keep, like, peek of 0 is weird to me, because why would you peek of 0, but we'll give this a try. Let's, yeah, because next is in the outsides. Fine, I wish I knew a better name right now, but I don't. Okay. If next token is equal to kind, is equal to syntax. Oh, next token 0. Okay, fine. Syntax kind. Okay, let's do this. Not equal to syntax kind update line count token. Okay. Well, then we don't know what it is. We expected that it should be there, but it's not. What we should have is a comma, but what I'm doing is I'm checking for the comma and the semicolon token and everything else later on. So if it's not, if all I got was a number, then line number dot. Yeah, so this actually, okay, then what I can do here is say line statements add. And this is going to be interesting because I need to essentially synthesize. Well, no, should I really be? No, that's being too cute. I think what I should do is I have an update line count expression syntax. And I don't want to try to have like 2 constructors for it. That doesn't feel right either. Yes, unary line count expression syntax. I already had thought about that. So let's do that. Okay. And we're going to take the same thing as an update line count expression. Get off of there. Okay, so CL class, which is an expression syntax. And we'll just grab all this. And I have to remember to, because like the last time I did it, as I go up the tree, number. I'll call it line number. Which equals line number, and that is the only thing that's omitted from this, so we don't have these, and we need a unary, and then we'll move it, see it's made, that's good, okay. So then here, we go back to the parser. We'll say line statements add new unary line count expression of line number. Line statements. What's wrong with this? Oh, we need to put that in a new expression statement syntax of a new unary line number. There. And then we say else because we do not want to do that again. Okay. Now, if I just run this, not that. Not that. So if I say 2, 3, I say run. Oh yeah, because that's actually, this is good because this is from the evaluation and it's saying I couldn't find 2. Which actually I'm not sure if that's correct because if I was reading this right, if the line in question is not on the to-do list, nothing happens. So I don't think that's actually right. So while we're here, let's go into the evaluation engine. And we should say, well, I'm relying upon it just working. And that's actually not true. So what I should do here is say to do from the spec, it says ensure that if a line number is given that isn't in the lines dictionary, we can't fail with a key not found exception or whatever it was. Okay, so I'll handle that later. I just want to make sure I caught that. So that's good. Now we have to handle this, but of course the parser will get to the binder. So what I need to have here is a bound unary line count expression. Crap. Update. That's what I meant. Yes. Yes, that was right. I just didn't have the name of the class right. Okay, that's fine. Okay, so then this becomes update that bound expression line number, this jazz again, line number. Oh, I should do that. And then we just do line number. Get properties. Yeah. No. We need to do unary. And then do that. And then do this with the stuff and the things. Line number, operator kind we don't need, right? Okay. Now that does that. But now in the binder, I should have just used that. Okay. Who calls this? So now we just say here, unary line count expression, unary, and now we make a unary. Okay, generate the method. Let's put it where that is, so we're close. Var bound line number. We bind the expression of the line number, and then we return a bound unary line count expression. New. Told you, it was going to be short. I cursed it. Bound line number. Okay. Alrighty. Now, okay. Yeah. Alright, well, whatever. Okay, now the evaluator. When we do a bound unary line, now we need to do an evaluate of a unary line, generate that method, and we're going to do it pretty much like this, except we're going to say var line to update is line unary line number. Okay. And then we need to say the count is if line to update is greater than big integer 0, then it's big integer, oh yeah, big integer 1, else it's minus big integer 1. No, that's not true. Else, if line to update is less than big integer 0, then we do minus big integer 1. Else, we do big integer 0. That's probably a very convoluted way of saying the same thing, but then we say actions, update count, and we're done. And it's just that simple. Let's make sure we didn't break anything. 3, 2, 1, minus 4, run. Okay, we got the right stuff here. Okay, so now let's do clear. Let's say 1, 2, that's it. And then 2, 1, minus 2. So what do we get? We got a unary update line count expression, numbers 2. And we got a unary update line count expression, where its little expression is a big integer of 2. Very nice. So now if we do 1 minus 2, and then let's do minus 3, okay, 2, 1, we just had 2 there, 3, 2, minus 1, run. And that bombed. Why did that bomb? Oh, I did it wrong. Yeah. That's not right. Oh, yeah, okay. That's actually, okay, I think I know what I did wrong there. Because this still needs to be the number 2. Okay, so let's actually copy that quickly. Okay, so I remember what I did. But what I need to do here is the absolute value of that. Right? Right. Okay. Now let's run this one more time with feeling. So let's just grab these lines as I did them. And one more. There we go. There we go. So, 1, 2, 3, 2, 1, 2. So we still capture it as a minus token. What's interesting is that the line says the literal expression here is a 1. Oh, the negation expression. Okay, I am catching the negation expression. Okay, cool. So yeah, good. And we're ending pretty much still under time, so that's good. I will commit all this, and I will keep producing more stuff, and hopefully I can actually get to the point where I can start actually calling methods in whatever. Dub sharp. That will be fun. So, thank you all for watching. Leave comments and questions below. See you in the next episode.